It looks like we got some kind of...
Hello, everyone. I'm Steve.
Man. And I'm Scott.
And we're Backyard Musings, broadcasting live Apple Valley.
We are the Science and Technology channel, and we also do a little moving on the side.
Man,
so that's why we're a little
there's
pooped.
about 10 of us last night from church. We packed up my neighbor. They
Loaded
sold
up
their
some
house.
Stuff. Yep.
Oh, my gosh. Everything is hurting.
Sad to see them
My
go.
nose hurts.
It was a long day, yeah. 4 or 5 hours for some.
4.5, yeah. 4 to 8:30.
Yeah.
Oh, man. So we're tired. And sorry.
Kind of tired.
Sorry about
good.
that.
We got a couple of good subjects to talk
We do have
about
some
today.
good subjects. As rare as a Bigfoot sighting, astronomers have recently uncovered a groundbreaking discovery, a frozen ocean world hidden within the asteroid belt between Mars and Jupiter. This astonishing celestial body, initially thought to be just another lifeless asteroid, reveals vast expanses of ice-covered oceans beneath its rugged surface, potentially harboring crucial clues about the early solar system and even extraterrestrial life. Equipped with advanced telescopes and innovative imaging techniques, scientists have begun unraveling the mysteries of this intriguing world, reshaping our understanding of planetary formation. This discovery not only challenges our perception of asteroids, but also ignites fresh excitement in space exploration and the ongoing quest for life beyond Earth. Would you like to know more?
The remarkable discovery was officially announced on October 10th, 2023, during a press conference hosted by NASA in collaboration with the European Space Agency, which is ESA, like our NSA or NSA, NASA.
That's it.
Yeah, utilizing data collected by the James Webb Space Telescope. And ground-based observatories, astronomers detected distinct spectral signatures indicative of vast subsurface ice layers. Scientists from NASA's Jet Propulsion Laboratory, ESA's Planetary Science Division, and several prestigious universities jointly analyzed the findings to confirm this unprecedented discovery. Those collaborative efforts underscore an exciting milestone in planetary science, demonstrating how international cooperation and cutting-edge technology can unveil hidden worlds within our cosmic neighborhood.
Are we gonna cancel this planet like we canceled Pluto? We gonna call it a planet? What are we gonna do?
Well, I think they refer to it later on in our story here as it could be classified as a dwarf planet.
A dwarf
right?
planet, yeah.
Isn't that what they've done with Pluto?
Pluto is a dwarf. Yeah,
which we're not
I'm pretty sure.
Dwarf or
is it not politically
small
correct?
People, right?
It's not politically correct.
Yeah, no, I don't think so. But I'm not very politically correct. But yeah, it's why dwarf planet? I mean, what?
No, Venus is smaller. It says
Venus.
It's about
Venus is a small planet.
Mercury.
Mercury is even smaller. I think.
Yeah.
I think Mercury is the smallest, other than maybe Pluto. So,
do you think Mercury could be an asteroid?
No, I think it's a planet.
You think it's a planet?
But okay. I'm thinking. So, who's doing that? Who's reclassifying these planets? I mean, we've talked about Pluto before. We don't need to get off on a tangent.
Someone trying to set the narrative.
That was in my solar system when I was growing up, right?
Yeah, me too.
So, anyway, here we go.
This newfound frozen ocean world resides comfortably within the heart of the asteroid belt, orbiting approximately 400 million kilometers from the sun. Positioned strategically between the orbits of Mars and Jupiter, it occupies a relatively stable zone. So Mars is the fourth, Jupiter is the fifth. But there's a belt in between their asteroid belt. Avoiding intense gravitational interactions with these neighboring planets, its precise location places it closer to Jupiter's orbital path, roughly 2/3 of the way from Mars, offering astronomers a unique vantage point to study planetary formation in this dynamic region of our solar system. This intriguing placement hints at a complex geological history shaped by interactions with both rocky asteroids and gas planet influences.
In terms of scale, this newly discovered frozen ocean world measures approximately 1,200 kilometers in diameter, making it slightly smaller than Earth's moon. That's pretty. That's pretty big. Though,
right? It is big. Yeah.
Which spans roughly 3,474 kilometers. Its size places it firmly within the category of dwarf planets, comparable to celestial bodies such as Pluto and Is that Ceres?
Ceres.
Although smaller than Earth, which is a diameter of about 12,742 kilometers, this intriguing object is substantial enough to have achieved a spherical shape under its own gravity.
Nice.
Okay. Its intermediate size and icy composition offer astronomers a compelling opportunity to better understand the diverse range of planetary bodies within our solar system.
What else is out there? If this guy was hiding in the belt, what else is out there?
Yeah. And do we need to maybe find some better lookers? Because, I mean, how long have they been looking at all this stuff? You know, they've known about Pluto, which is way out there.
James Webb is in orbit, the telescope. So,
right.
I mean, we're just starting to.
It's moving around.
There's only 24 hours in a day. Scientists can, they got to aim that telescope a certain way.
I get it. It's like
put some more telescopes up there.
A battleship, right? Yeah.
Right.
Not like turning a tugboat.
So I just had a thought. We need to name this planet. It's a planet, okay? Can we agree on that? We need to name it.
Yeah. Dwarf or not, it's a planet.
So we want you, tell your friends, your enemies, everyone, of course, to subscribe. But we need a name for this planet.
Not a number.
Not a number. No, a name. Could be Roman name, like Jupiter is, the largest. That's like Zeus,
It's supposed to have an ocean on it, right?
Yes, frozen ocean. Hoth? What about Hoth?
Ocean 11.
Oh, Ocean 11.
That's a number, but Ocean 11.
So give us
a movie, right? Ocean 11.
Yeah, that was a movie.
Yeah.
Give us give us what you think. Come on, comment, people. Come on.
Well, which planet would this be? The 11th planet?
No, 10th, wouldn't it?
10th planet. Ocean 10.
Pluto is 9. In this one,
Pluto.
Hoth. In the Hoth system. Okay.
Hoth.
Yeah, whatever.
Okay.
Spectral analysis has revealed that this icy world boasts a frozen crust primarily composed of ice water, interspersed with traces of ammonia and carbon dioxide. These fascinating findings suggest that beneath its brittle surface lies a complex chemistry shaped by prolonged exposure to cosmic radiation and extreme temperatures hovering around minus 200 degrees Celsius.
The reflective crystalline ice layer detected by astronomers points towards geologically recent resurfacing events, potentially driven by internal processes or external impacts. Such conditions offer researchers a rare glimpse into a preserved environment, providing invaluable data to better understand the evolution and stability of icy bodies within our solar system.
We need to get a probe out there, a Class 3 probe.
Yeah. Well, they're going to
check it out.
They want to do that, right?
Yeah.
They want to go in there and drill.
Yeah. Compelling data derived from gravitational measurements and radar imaging strongly indicate the presence of a vast subsurface ocean beneath the planet's thick icy shell. These observations closely resemble findings from renowned ocean worlds within our solar system, such as Jupiter's moon Europa. We got a mission going to Europa. Mm-hmm. And Saturn's moon Enceladus. I never heard of Enceladus. That's pretty cool.
We're just not in the loop.
We're not in the loop. Both known for their hidden liquid water oceans.
Scientists believe tidal heating and radioactive decay may maintain liquid water reservoirs beneath the frozen surface, potentially creating environments conducive to life. Such similarities not only deepen our curiosity, but also position this distant world as an exciting new candidate in the broader search for extraterrestrial life. Okay.
Much like Jupiter's moon Europa, this newly discovered frozen ocean world exhibits remarkable parallels in oceanic composition and potential habitability. Spectroscopic studies reveal similar icy crust compositions, rich in water ice and infused with chemical compounds such as ammonia and carbon dioxide. It's infused. It'd be a delightful drink, a cocktail.
Ammonia?
It's infused?
I'm not drinking ammonia. I can't even put it up to my nose. Beneath their frozen surfaces, both celestial bodies likely harbor liquid water oceans, warmed by internal processes such as tidal friction and radioactive decay. These shared characteristics raise compelling questions about the possibility of microbial life existing deep beneath their ice-covered surfaces, positioning this asteroid belt world as an exiting analog for future Europa exploration missions.
Could be exciting. Could be. The discovery of a subsurface ocean beneath this world's icy crust significantly heightens the possibility of microbial life thriving in its hidden waters. Astrobiologists highlight that similar extreme environments on Earth, such as deep sea hydrothermal vents, we've talked about those, and subglacial lakes, that's in Antarctica, host diverse microbial ecosystems adapted to conditions devoid of sunlight and oxygen.
Given the chemical composition detected so far, scientists speculate that energy-rich reactions between water, rock, and organic molecules may sustain primitive life forms beneath the ice. Future missions equipped to probe beneath the surface could ultimately confirm whether this distant oceanic realm harbors extraterrestrial biology, reshaping our understanding of life's cosmic prevalence.
Scientists are actively exploring several intriguing hypotheses to explain how this frozen ocean world formed and ultimately settled within the asteroid belt. One prevailing theory suggests it originated farther out in the solar system, possibly beyond Jupiter, before gravitational interactions pulled it inward to its current orbit.
Alternatively, researchers propose it could have formed directly within the asteroid belt, accumulating ice-rich material during the early stages of planetary formation. Advanced computer simulations and ongoing astronomical observations are helping astronomers trace the planet's evolutionary path, providing vital clues about the dynamic processes that shaped our solar system billions of years ago.
This newly discovered frozen ocean world completes an orbit around the sun approximately every 5.2 Earth years, closely aligning with Jupiter's own orbital period. Its trajectory exhibits moderate eccentricity, indicating a slightly elliptical orbit that periodically alters its distance from neighboring celestial bodies.
Gravitational influences from Jupiter and to a lesser extent Mars play a significant role in shaping its orbital stability, occasionally affecting its axial tilt and rotational dynamics. Understanding these orbital characteristics provides astronomers with valuable insights into its geological history and potential habitability. As the gravitational interplay likely contributes to internal heating and ocean maintenance beneath the icy surface.
So if Mars needs some water, they can jet off to this planet and then
pump it out,
get down and get the ice. Start breaking up the ice.
Take it back.
Put it like in a big net in orbit.
By the time it's back, will it still be ice?
Yeah, it's in the vacuum.
Okay.
Yeah. Excited by this remarkable discovery, space agencies worldwide are already proposing missions aimed at exploring this enigmatic, why don't we call it Enigma? Enigmatic frozen ocean world. NASA and ESA have begun preliminary studies for a joint robotic orbiter scheduled tentatively for launch in the early 2030s to map surface features and probe subsurface layers using advanced radar imaging.
Additionally, researchers are advocating for a dedicated lander mission capable of drilling through the ice crust to directly sample the hidden ocean beneath. These ambitious exploration plans promise to deliver unprecedented insights into the distant world, potentially revealing clues about the origins of life and planetary formation.
The discovery of this remarkable frozen ocean world between Mars and Jupiter marks a transformative moment in planetary science, profoundly influencing our understanding of the solar system's formation, evolution, and potential for supporting life. Its subsurface oceans, unique orbital dynamics, and accessible resources present compelling opportunities for exploration and research.
As international agencies collaborate on ambitious missions to unravel its mysteries, scientists, policymakers, and educators, and the public find renewed excitement and curiosity in humanity's cosmic journey. This groundbreaking revelation invites us all to support continued exploration, ensuring we remain dedicated and united in uncovering the secrets of our celestial surroundings.
All right, folks, let's come up with a name. Put it in the comments.
Cool. Yeah, let's name this planet.
Let's do it.
Yeah, and no dwarf names.
No midgets.
Yeah, no.
Like Tyrion.
Oh,
Tyrion!
Who is that?
That's from the Game of Thrones. The midget, the dwarf.
Oh, see, there you go.
Tyrion.
Okay, whatever.
Oh, I just won the contest. Oh.
Are we allowed to enter the contest?
No. All right, folks. Thanks a lot.
Take care, everyone. Thank you.
See you.